Hi, this is Wendy, and in this series of videos, we're learning how to write our own object-oriented classes. In the first video, we learned how to create and use a basic class. In the second video, we learned about constructor methods. In this video, we're going to talk about accessor and mutator methods. In the fourth video, I'll show you how to create a toString method to display objects, and in the last video, I'll show you how to compare objects for equality and identity, and we'll review the difference. When we create classes, one of the things we have to consider is what data values are allowed to be assigned to the class's data members. For example, if you had an account class that modeled a bank account, you wouldn't want someone to be able to assign a negative balance to that account. Similarly, if you had an employee class with a member for the employee's department number, you wouldn't want an invalid department number to be assigned. For example, if the department numbers ranged from 1 to 10, you would want to make sure that a value less than 1 or greater than 10 could not be assigned to the department number member. Protecting your data members from invalid values involves a series of changes and additions to the classes we've written so far. Let's start with our MyMessage class. Let's say we decide that we don't want the message member to be a null value ever, and we don't want it to be an empty string. We want to make sure that whenever the programmer assigns a new value to message, it's always a valid string object that isn't empty. The first thing we want to do is change the modifier on our instance variables. Public means they can be accessed by any class outside of the MyMessage class, and we don't want that. Instead, we're going to change this to the private modifier. In UML, we show the private modifier using a minus sign instead of a plus sign. An instance variable with the private modifier is only accessible inside the class in which it's defined. So this means our message variable is now only accessible inside MyMessage and nowhere else. So inside my message class, I'm going to take the public and switch it to the keyword private. This means now message is no longer accessible outside of MyMessage. It's perfectly fine to access it inside MyMessage, but it's no longer accessible outside of MyMessage. For example, we had code from one of the previous videos where we used the default constructor to create a new message and then change the message member value to boo. If I now recompile this program, it's going to give me an error on that line of code. The error says that the message member has private access inside the MyMessage class. So I can no longer directly access the message member of the MyMessage class. Right now, the only way to assign a message is via the constructor. If I were to comment out these lines of code, then the program will compile fine. The only way now that I can assign a new message is to use the constructor method. But what if I want to change the message to something else after I construct it? We need a way to change the message. The purpose of accessor and mutator methods are to provide limited access to private data members. For example, such a method can examine the programmer's specified value to make sure it's valid before assigning it. The employee class could have a setDepartmentNumber method that accepts a department number from the programmer, and if that department number is between 1 and 10, it's assigned to the department number member. But if it's not, we can show an error message or do something else. Accessor methods provide read access to data members. They allow you to retrieve a private data member's value. Mutator methods provide write access to a data member. They allow you to set or change the data member's value and will even perform validation to make sure that the member only receives valid values. You'll see that accessor and mutator methods must be defined an exact way. That standard that we're following is called the Java Bean standard. A Java Bean is a class that models real-life objects and has constructors, accessors, and mutators. It's important to follow the Java Bean standard because in later courses you'll learn things like JavaFX and Spring Boot, which can only do certain things with your beans if they follow the Java Bean standard. If your classes don't follow this Java Bean standard, you won't be able to use them with JavaFX or Spring Boot unless you add a lot of extra code. Now let's do mutators first because they do require the most coding. A mutator method must be defined as follows. It must be public, it must return void, it must be called set in lowercase letters, followed by the data member name in title case. That makes the entire method name camel-cased properly. It must have a single parameter whose type is exactly the same type as the data member. The parameter name can be any valid and standard variable name. That's because we use this set method to place a valid value into the data member. Therefore, this parameter is going to contain the value to place in the data member. That's why the data type has to match the data member type. For example, if you have a book class and it has a private string member called book title, then the mutator method must be defined as public void set book title camel-cased with a string parameter. In this case, I just called it title because I was running out of room. Because the methods always start with set, many programmers call mutators set methods or setters. I actually hate calling them setters, but you can call them setters if you like. So in our myMessage class, the mutator for the message member will have to be defined as public void set and then message in title case, and it must have a string parameter, and I'm just going to call it message. There's not many other things we can call it. In terms of where your mutators and later your accessors should go, most programmers will put accessors and mutators after the constructors, but before any other methods. I don't know why, it's just the way we do it. It's probably because that's usually how they appear in the UML, and it's just easier to follow the order of the UML. So you should be doing the same thing. So our mutator method is public, it returns void, and it's called set in lowercase letters, followed by the name of the data member, but we have to capitalize the first letter so that the entire method name is properly camel-cased, and we must have a single parameter, and it's only ever one parameter. A mutator method should not have more than one parameter. It's always exactly one, not 0, not 2 or 3, but 1. So we have that single string parameter. It's a string because the private message variable is a string, so they have to match. Now we can code the body of the method. We need to examine this message parameter and determine if it's valid. The message parameter is valid if it's not a null object nor an empty string. If it's invalid, we don't want to assign it to the message member. So how do we go about doing this? When dealing with an empty string in Java, you have to be concerned about two things. First, is there no string object in the variable? In other words, is the variable, the string variable, equal to null? Second, if there is an actual string object, but the string's value is empty. In other words, a null string, which we depict using the double quotes with nothing in between. There's a big difference between a null object and a null string, or it's easier to say an empty string value. So let's talk about what the difference is, and then we'll talk about how to deal with it. Let's start with a null string or empty string value. Now recall that there are two areas of memory being used when you work with objects and variables, the stack and the heap. Variables are in the stack and objects are in the heap. Here, when I create the string object and assign it a null string or empty string, I still create a string variable in the stack. And when I assign the empty string, my string object gets created in the heap, but the value property is set to the empty string value. And as usual, the address of that string object is still assigned to, in this case, the dog name variable in the stack. So here, the dog name variable references or points to the string object that happens to have an empty value. Creating a null object looks different. When I create a string object that's null, that's when I do something such as string fish1name and then semicolon, so I'm not assigning it anything, or fish2name and I actually am assigning it null, which we might do if we wanted to initialize a variable. You'll see later there's some instances where even if you want it to be null, there are times when you do need to still initialize a variable to null. So if you assign nothing at all, or you assign the keyword null, you're creating a null object variable, a variable that doesn't reference anything at all. So when you assign nothing at all, or you assign the keyword null, you're creating a null object variable, a variable that doesn't reference or point to anything at all. The null keyword is like a 0 for ints, or like a null string value is for strings. It's nothing. It means it's a nothing value for objects. So these statements only create the variables fish1name and fish2name in the stack. They don't create any objects at all in the heap. So both fish1name and fish2name are referencing nothing or referencing null. No string object was ever created or constructed. The variables don't reference or point to anything in the heap. In other words, the variables point to null. Now, how you test for an empty string value and a null object are completely different. To test if a string variable is not pointing to any object, you simply check to see if the variable is pointing to null using the double equals operator. This expression returns true if the message variable contains null, or in other words, if the variable contains no memory address, if it's pointing to nothing. To test and see if a string has no value, we must use what we call an equality comparison. You might be tempted to do something like use the double equals operator to see if the string equals a null string or an empty string value, and this is actually incorrect. Remember, the double equals comparison operator in Java does an identity comparison. That means it's actually checking to see if two object variables point to the same object, or in other words, contain the same address. What we really need to do is an equality comparison, which compares string values inside string objects. You actually have a choice of two methods for this. You can either use the equals method on the string and pass it the null string character, which remember is two double quotes with nothing in between, or you can actually use the isEmpty method on your string, which will always return true if the string's value is empty and false if it's not empty. So now we know that we need to perform two kinds of string comparison, one that checks to see if the object is null, and one to see if it's an empty string. So in my mutator method, what I could do is perhaps say if my message is empty, so why not? We haven't used this method before, we might as well give it a try, or if my message is equal to null. So that means if it's invalid. If it's invalid if it's an empty string value, or it's invalid if it's a null object. And then my else would be if neither of these are true, if they're both false, then it's going to be a valid value. So this is valid and this is invalid. Now there's actually a problem with this, and that's that this will crash if the message parameter is in fact a null object. But why? It's easier to demonstrate this using a different piece of code. So here I'm creating a string object called str, and I'm assigning it null. This string variable is not pointing to any object in memory, and then I'm going to invoke the isEmpty method, which you might think, well, it's an empty string, right? No, it's a null object, which is a different thing. Let's find out what happens. When I save, compile, it compiles fine, and execute, I get an exception. You'll see this exception a lot. This exception is null pointer exception. It's actually self-explanatory. It's saying that there's an error, and it tells you it's on in my code, on line 13, which is this line of code. When you see null pointer exception, it means whatever object is in that line of code is null. It's pointing to null. It's pointing to no object. A null object, you cannot invoke a method on an object that doesn't exist. When you look at the code in our mutator method, the problem is that if we do somehow pass a null object in as our parameter, then this isEmpty method is going to crash because you can't invoke a method on a null object. So now we wonder, how the heck can I check for a null or empty string if it's going to crash? Thankfully, you might remember that Java logical operators use lazy evaluation or short circuiting. We can use this to our advantage. If we reverse the two conditions, we can take advantage of the short circuiting of the OR operator. So I'm going to move these on opposite sides like that. So now I have the if message is a null object or message is an object, but the string value is empty. The difference is that with an OR, remember that if the first condition is true, it won't bother checking the second condition. So if message is in fact a null object, it's going to go ahead and execute the if block. It will not execute the is empty, and that's good because if it did, it would crash. So this will actually work. If message is null, it's not going to invoke is empty on a null object. If it's not null, then it's going to have to check and see if it is in fact an object, which it must be if we get here, see if it's empty. And if it's empty, then it will execute the invalid code, otherwise it will execute the valid code. So that's how you should usually check for an empty string. Always check for null first and then check the string value. Now, if you want, you can write your if to say if it's valid, do whatever, otherwise it's invalid, do something else. If you learned about De Morgan's law in your math class, then you already know how to do this. We basically want to say the opposite. This says if it's invalid. What we want to do is say if it's valid, then go ahead and set it, otherwise it's an error. So De Morgan's law says that A or B is exactly the same as not A and not B. So not A is message not equal to null, and not B would be message is not empty. So not message dot is empty. This is actually a less efficient statement, because you have more operators. We have this extra not operator, for example, so technically this is actually less efficient, but you know, you could also argue that most of the time you're likely going to have valid messages, so you're going to have to go to the else block fewer times, and that's a legal argument as well. So you could do it either way. Do it whichever way you think is best for your program. So I could do it this way, where this would be valid and this would be invalid. This also will short circuit. So for example, if message not equal to null is false, meaning it is null, right? So this is not equals. Then the AND operator knows that if the first condition is false, the whole thing must be false. So if it sees that it is null, it will stop and go execute your else block without actually executing the isEmpty method. So you could write your mutator that checks for a valid string in either one of these two ways, as long as you make sure the null check is first in your if statement. Okay, now that we know how to write it, what do we actually do? So if it's valid, we want to take the message parameter and assign it to the message data member. So if you're doing in this version, you would do that. Otherwise, you would put it in the else block. Depends on which version you wrote. So this dot message equals message. Again, if the message parameter is valid, then it's safe to assign it to the data member. But if it's invalid, we want to let the person know that it's not valid. So you might think we should probably display something on the screen, but again, that's actually a bad idea. If we display something on the console using, say, println, print, or printf, then our class is no longer reusable to any type of application except a console application. We won't be able to use it in an application with a graphical user interface or a mobile application, for example. Remember, we want to make our classes like Lego blocks. We want to be able to use them in any kind of program without having to modify anything inside the class. Thankfully, Java has a solution to this. In the past, we talked briefly about exceptions. Exceptions are thrown or occur while your program is running. Exceptions that occur are actually objects. When an exceptional circumstance happens in your program, the code instantiates an exception object from one of the hundreds of exception classes in Java. That exception object is then thrown. The result of this so far has been that you see a stack trace in your output window, but later you'll learn about other things you can do with that exception. Now, there happens to be an exception class called illegal argument exception that was created specifically for this exact situation. When your mutator finds an invalid value, it should construct and throw an illegal argument exception. To do this, we first construct a new instance of the illegal argument exception class, and in the constructor, we pass it a nice friendly error message. In this case, a nice message, and we've talked about this before, should specify what's wrong and suggest how to fix it at the same time. So for example, error message can't be null or empty. So that tells the person what the problem is and suggests how they should fix it by making sure it's not null or empty. The next thing we want to do is we now want to take the object that we're instantiating and we want to throw it out of this message. And we do that by using a throw statement. Just like that. Now I am going to have to wrap this a bit because it is running off the page there. Oh, it's going to run off the page anyways. So I'm going to have to do one of these, and that's fine. It's just the way life is sometimes. There we go. So I am constructing a new illegal argument exception with a friendly error message, and then I'm throwing that. That, you can think of it like it's actually throwing. It will throw that out of this mutator method, and it will end up in the calling program, which probably will just print a stack trace on the screen. Now this single statement is actually the equivalent of these two statements here. But since we don't need to keep the exception object in a variable, it's not really necessary to write this in two statements. Most programmers will write it as a single statement. This basically says construct an illegal argument exception and then go ahead and throw it. So now if we use this mutator method in our test program, let's say we construct our myMessage hello, and now we want to change the value of hello using setMessage. So if I were to pass it, for example, a null string, we're going to see what happens. When I pass a null string, it's going to come in here and it's going to check and see if it's not null or it's not empty, then it's going to go ahead and set it. Now, when it does this test on my null string, this one is going to be true. It is not a null object. It is actually an object, but this one is going to be false because it is empty. This says, is it not empty? No, it actually is empty. So that means this will be false. Don't you love double negatives? So it's going to go to the else block and it's going to throw the illegal argument exception. So let's actually see what this does. So when you execute the program, I see the output hello because that's when I displayed the message first. And then I get exception in main. It is a illegal argument exception, and look, error, message can't be null or empty. Oh, that's the error message we typed. So this is what is supposed to happen. It is up to the programmer using your class to make sure that the user doesn't see this. They're supposed to figure that out themselves. And we learned a whole lesson on data validation. Obviously, we already know how to do that. But this is how you would write your classes. When you create a mutator method, you do your data validation inside the mutator, and if anything is invalid, you throw an illegal argument exception. Now let's deal with the accessor method. The accessor method's job is to allow us to read the value in the member. Right now, if we wanted to see the message member's value, we'd have to use the display method. We can't just say .message anymore. An accessor method must also be defined in an exact way. So it's defined as follows. First, it must be public. It needs to be accessible outside of the class. It must also return the exact same data type as the member that you're getting or retrieving. It also must be called lowercase get, G-E-T, followed by the data member in title case such that the method name is now in proper camel case. And lastly, it can't have any parameters. No parameters are needed by the accessor method because its job is to simply retrieve the private member's value. For example, if you have the book class and it has a private string member called book title, then your accessor method would be defined as public string get book title. Because these methods always start with get, many programmers call them get methods or getters. And again, I hate calling them getters. I don't know why. So in our myMessage class, if we were going to create an accessor method for the message member, then I would start with public. It has to return a string, and it's called getMessage, no parameters. And now what goes in the body of this method? Well, this is actually really easy. The purpose of this method is to give you the value inside the data member. So all it needs to do is return that value. You simply return the data member, except it has to be spelled right. There we go. That's it. Now this may seem like a waste of code, but remember, by making message private so we can protect it from invalid values, we can no longer read its value outside of the class. So we have to have an accessor that gives us a message member's value whenever we need it. Now you might encounter some classes where you might have other bits of code in the accessors, but generally this is all they do. So now we can actually try it in our test program. In our test program, if we ever wanted to retrieve the message, for example, if we wanted to, instead of going through the display message method for whatever reason, if we wanted to just print the message directly, we would say messageObject.getMessage. It's kind of a stupid example because the display method kind of does the exact same thing, but it'll be a lot more practical in the other classes. Oh, I have to actually save my message class first before I can compile this one. There we go, that's better. So when I execute, there you go. See, this is kind of a dumb example, but it'll get better when we look at the other examples we've been working on. So now we can retrieve our message anytime using the accessor method, and we can change the message value anytime by using the mutator method. Now, what happens if I do something like my message boo equals new my message, and I pass the constructor a null string? Now we've already established that a null string or empty string is not a valid message. So do we expect that we would see our illegal argument exception here? I mean, we should, right? However, when I compile and execute, you'll notice I get no error at all. I'm not actually displaying it, so ignore the hello, but it doesn't give me an error, and that's the important part. So when this statement executes, the constructor will take the null string. It's going to invoke the matching constructor method, which is this one. So that message parameter contains the null string, and it goes ahead and it sets it. Oops, we've left a hole in our program. So a programmer can assign an invalid value to our message member via the constructor method. It's kind of like, imagine your mutator method is like the bouncer at the door of the nightclub. The bouncer decides which people get to come in and which people don't. That's what the mutator does. But let's say someone tries to get in and they can't. So they go around the back of the club and find a back door and they sneak in that way. And that's kind of what's happening here. The null string snuck in through a little back door, which is our constructor method. So we can fix this. And this is traditionally what your constructor method should do, is they should not allow invalid values into the data members. Since we have a method called setMessage that validates the message parameter for us, we might as well use it. So what we do is call setMessage and pass it the message parameter. So now, when we try to call the constructor and pass it an invalid value, it will take that value and say, hey, mutator, you can validate this. Go ahead and do that. So it will validate the message, in which case, because it's a null string, it's going to throw an exception. That exception will be thrown into the constructor. The constructor sees it and says, well, I don't have any code to handle this. So it throws it back to the main method, and it'll end up here and show the illegal argument exception on the screen. There we go. So there's our illegal argument exception. And notice in the stack trace, it says it found it on line 20 of the myMessage class, which is here. That's the statement where we threw it. From there, it got there. Whenever you see this init, that means a constructor. So it got there from a constructor on line 10. So line 10 is here. That's where it called that setMessage method. And it got there from your test program on line 12. That's why this is called a stack trace, because it traced all the way back to where this began. So the problem happened on line 20 in the set method, and it got there through the constructor and from there from your main method. Anyways, there we go. Now our message member is fully protected from receiving invalid values. Always make sure when you add mutators to your class that you also invoke them in the relevant constructor methods. You don't need to do this in the default constructor. For example, if we're using the hello world default, if I didn't do it up here, let me just do it this way. Oh. There we go. So if instead I was initializing my data member using the default constructor, right, it would be kind of silly and a waste of processing to do this. I've seen students do this when they're not paying attention to the videos and the notes, unfortunately. Don't do this. So I'm going to put a big no. Don't do that, because this is a waste of processing. Remember that methods are extra work for your program. If you're typing a literal default value like hello world, it must be valid. You would never type an invalid literal value in this kind of situation. So there's no point in calling the set message method to validate your literal. It's better to just leave it as is. That way. If that's the way you're doing it. If you were doing it this way and initializing in the declaration, then you're fine. Don't worry about it. Okay, let's do one more example. In the previous video, you created the room class. So let's add accessor and mutator methods for both the length and the width data members. Both members must have positive non-zero values. So here's our room class. The first thing we want to do is make our data members private so that we can protect them from receiving invalid values. And the next thing that we want to do now is create the accessor and mutator methods, and that will allow limited access to the length and width outside of the room class. Again, we generally create accessor and mutator methods after constructors, but before the other methods. And many programmers like to do the accessors first because they are the easiest. So I'm going to start off with my accessors. Accessors are always public. They always return the data type you're retrieving. In this case, they're both going to be double. And they're called get, followed by the data member name. So in this case, get length. And there's no parameters. And similarly, public double get width, and again, no parameters. And all we need to do inside these methods is return length and return width. And if I wanted to document these properly, I'd probably say something like retrieves. Again, don't say get, because the method name already says get, duh. Retrieves this room's length. Good enough. And then for the same thing for width. So retrieves this room's width. That's the easy part. Next part is our mutator methods. So mutator method for length must be public, must return void, must be called set length, and must have a parameter that is the same type as the data member, in this case double, and I'm just going to call it length. And the job of this method is to make sure that length is not 0 or less. Again, you want to write your if statements in the most efficient way possible. Most of the time, people are going to be passing in valid lengths. So it's more efficient to say if the length is valid. So if the length is greater than 0, then we can go ahead and say this dot length equals length. Otherwise, it's invalid. And I want to throw an exception. So throw new illegal argument. This one's easy to type incorrectly. Illegal argument exception. Give a nice, useful, helpful error message. Error. Length must be greater than 0. I'm running out of room. That's okay. There we go. And the mutator method for set width. Public void set width and double width. The nice thing about these, they're looking pretty similar, and that's the way it's always going to be. Your accessors and mutators are going to follow pretty much the exact same pattern in every class that you write. Just the validation will be slightly different. But that's a nice thing. That means the more you type this, the less you're going to have to memorize for your final exam. This dot width equals width. And if it's not valid, I want to throw a new illegal argument exception. And let me just get all this in there. Error. I just noticed I spelled length wrong again. What's that, the 5th time in this video? Error. Width must be greater. I know I'm going to have to do this. Than 0. There we go. Ta-da! And again, I probably want to document these nicely. Places a valid value into this room's width. Oops, nope. Length member. Cool. And let's just do this. And change the word length to width. There. There's our mutators. So there's our accessors and our mutators. Now, one more thing, don't forget. We don't want a programmer to be allowed to construct a room with an invalid length or width. So in the 2 parameter constructor, we should say set length and pass it the length parameter, and set width and pass it the width parameter. In the single parameter, it was the size parameter. So we're going to do set length and pass it size, and set width and pass it size. In the default constructor, we were just doing default values, which obviously are valid, so we don't have to do anything. There we go. So now, in our test program, if you wanted to, you can test this out by trying to give the room object, one of your constructors, an invalid value. For example, I'm going to pass in -2. And it compiles, but when it runs, it says, nope, error, length must be greater than 0. And it found that error on line 5 of my main because I tried to pass in a -2. It went into the constructor of the room class, and on line 28, that was this one because it invoked this constructor. On line 28, it called the set length and tried to pass it that -2, it ended up in the set length method. Where did you go? In the set length method on line 53, because what happened was it took that -2 and passed it to set length. It said, is that greater than 0? Nope. So it went into the else block and it threw an illegal argument exception with that error message. There you go. If you want, you can try some more. You can try the set methods if you like. They'll all work exactly the same way. Now try this exercise. Go to your item class from the previous video and create the accessor and mutator methods for the item ID, the quantity, and the price members. Item ID can't be a null object or an empty string. Quantity must be greater than 0, but the price must be 0 or more. We'll allow 0 because maybe something is free. Go ahead and pause the video, add the methods, and don't forget to update your constructors, and don't forget to change the modifier of your 3 data members to private. Then resume the video and I'll show you my answer. All right, now that you've had a chance to give that a try, here's the solution. So the first thing I did was I changed my data members to all be private. So all of them are now private so that they're only accessible inside the item class unless you go through the constructors or the accessor and mutator methods. In the constructors, I left the default constructor alone. There was nothing to do. But in the single parameter constructor, I had to invoke the set item ID method that I created. I'm going to show you that in a second. And in the 3 parameter constructor, I also invoked set item ID, set quantity, and set price. Make sure that once you create your mutator methods, that you update your constructors where necessary. Then I created, first I did the get and set for item ID. So there's my get item ID. All it has to do is return item ID. And my set item ID, so I checked to see, I did the validation the other way this time, just so you can see both examples. So if it's null or it's empty, I throw an exception. Otherwise, I go ahead and set it. And then I did the same thing for quantity. So get quantity retrieves the quantity, and then set quantity. If it's greater than 0, it sets it. Otherwise, it throws an exception. And then for price, again, I did the same thing. There's my get price. It retrieves the price as a double. And my set price accepts the price as a double. Make sure that it's greater than or equal to 0. If it doesn't, then it throws an illegal argument exception. So that's the basics of creating an object-oriented class. So you're going to find now that when you follow the Java Bean standard, most of your object-oriented classes are going to follow this exact same pattern of private data members, constructors that call the mutator methods, and then all of the different accessor and mutator methods for your data members. There are a few other smaller details, but we'll cover most of those another time. For example, in the next video, we're going to talk about the toString method and how we use it to display objects. So I'll see you over there. Thanks for watching.